changes in food webs. In this video, scientists will be able to analyze food webs in order to predict the effects of changes within an ecosystem. As a reminder, a food web consists of several food chains that are overlapping. And we create food webs because they're more realistic representations of an ecosystem. Within a food web, organisms are connected by lines or arrows that show the movement of energy from one population to another. So what can affect populations in a food web? How can populations in a food web get bigger, or get smaller, or disappear? There's two big ways to make changes in a food web. The first is to affect the access to food. So if a population has more food, well then you'll increase that population. That makes sense. If there's more food available, then a population can grow and reproduce more. If there's less food, well then that population will decrease. If there's less plants, then the animals that eat those plants, some of them will start to die and that population will get smaller. There can also be changes to the number of predators. If there are less predators, well then a population can grow. If there's less things eating a population, well then that population can get larger. The flip is also true. If there's all of a sudden more predators, well then the population being eaten will get smaller. So let's look at some simple examples. What would happen to the lizard population if the caterpillar population decreased? So if there was less caterpillars, what would happen to the lizards? Since lizards eat caterpillars, if there's less caterpillars, well then there'd be fewer lizards. How about what would happen to the lizard population if all of the caterpillars died? Let's say we completely killed all of the caterpillars. Well, since the lizards only eat caterpillars, if you removed all of their food, then the entire lizard population would die. How about what would happen to the bird population if snails increased? If for some reason the snail population got larger, well then the bird population would also get larger because there's more food for that bird to eat. That bird population could grow because there's more food available. What would happen to the rabbit population if eagles decreased? So in this example, I'm removing predators because the rabbits are being eaten by the eagle. So if there's fewer eagles, well then the rabbit population will get larger. There's fewer things eating the rabbits, the number of rabbits would increase. The opposite happens when you increase a predator. So what would happen to the snail population if the bird population increased? If there was more birds eating the snails, well then the snail population would decrease. Now, all of those examples we just went through are fairly straightforward, direct connections. More food, bigger population. Less food, smaller population. Less predators, bigger population. More predators, smaller population. But sometimes the connections you have to find are multiple steps. And when those connections get challenging, I think it's best to think about a food web like a maze. How can you get from one spot on a food web to another? Let's see some examples. So in this question, what would happen to the eagle population if the caterpillars decreased? Now this one's a bit tricky because eagles do not eat caterpillars. So I have to think, what is the connection between caterpillars and eagles? I'm thinking about it like a maze. Well, I can see that caterpillars are eaten by lizards, and lizards are eaten by eagles, so there's one possible pathway. If the caterpillars decreased, then the lizard population would also decrease, which means that the eagle population would also decrease. We normally don't think that something like a caterpillar could impact something like an eagle because eagles don't eat caterpillars, but they're connected through the food web. Here's another one. What would happen to the snail population if the rabbits increased? Again, rabbits don't eat snails, so how are those two populations connected? I'm going to think about it like a maze. Well, I know that rabbits eat grass and snails eat grass, so that could be a connection. If there's more rabbits, that means that there's more rabbits eating the grass population would decrease. And if there's less grass, that means there's less food for the snails, which means the snail population would decrease. What would happen to the lizard population if the birds decreased? Again, two organisms that are not directly connected. I could tackle this in two ways. If the bird population decreased, two things would happen. The eagle population would decrease because there's fewer birds to eat, and the caterpillar population would increase because they have fewer predators. How that relates to the lizard is if there's fewer eagles, so less predators, and more prey, there's more caterpillars, then the lizard population would increase. This is an example of competition within a food web. The birds and the lizards are competing, and if I have less birds, then I end up having more lizards. Let's try a final question. What would happen to the grass population if the eagles decreased? Now, this is an example where sometimes food webs have no easy answer. If I decrease the eagles, there would be less predators. And so I would have more lizards, more birds, and more rabbits. However, with more lizards and more birds, I would have fewer caterpillars and fewer snails, because lizards and birds eat caterpillars and snails. Now I'm stuck in a tricky situation where I have fewer caterpillars, fewer snails, but more rabbits. If I'm thinking about predators, well then I would have more grass because there's less caterpillars and snails eating the grass. But I would also have less grass because there's more birds and more rabbits eating the grass. Sometimes in food webs, there is no easy answer to say if eagles decreased, that grass would increase or decrease because there's so many connections between all of the different organisms. If you can explain all those connections, you're in good shape. And that leads us to our key ideas. Remember that in ecosystems, there's a movement of energy through overlapping food chains. Organisms are all connected to all of the other organisms in a food web. And food webs can change based on access to food and the number of predators.